Hello everybody. Today we're going to be talking about the volume of spheres. So this is going to be pretty straightforward because we're just going to have one new formula here to add to our volume formulas. So I think we're all pretty familiar with spheres. You can see a bunch of examples of these. As far as a definition goes, we say a sphere is the set of all points in space that are a fixed distance from a given point called the center, right? So if we think of some point in the center of that Earth there, the distance from that center point to any point on that sphere would be the same. And in fact, we know that fixed distance, right, is actually our radius. So the distance from the center to any point on that sphere. Okay, and so here's where we talk about the radius, right? A radius of a sphere connects the center of the sphere to any point on the sphere, just like we said. Okay, something important to know, we'll be working with hemispheres, which is just half of a sphere. So obviously if we start talking about the volume of a hemisphere is just going to be half the volume of the whole sphere. Okay, so here's our volume formula. The volume of a sphere with radius r is just going to be volume equals 4/3 pi r cubed. So volume equals 4/3 pi r cubed. So that volume just depends on knowing the radius. So now the volume of a hemisphere is just volume is 1/2 times that same volume times 4/3 pi r cubed. Now, you'll have a choice when it comes down to calculating the volume of a hemisphere. You could just leave it in this form and type it in exactly as it is into your calculator. Or, I know that 1/2 times 4/3, if I simplify that, is just 2/3 pi r cubed. So they both mean the same thing. It'll just be a preference for how you want to work with that formula. I like using this because then I don't need to memorize a separate formula for the volume of a hemisphere. So we're going to do 4 quick problems, won't take us very long, and then that'll be it for today. This is the last shape that we're learning the volume of, and then we go from here on to the volume of composite figures, just like we did with area. So 2 targets for today. One is being able to find the volume of a sphere, and then the second is finding the dimension of a sphere given the volume. And this will typically either be just the radius or the diameter. So for number 1, again, we're finding the volume and we're rounding our answers to the nearest tenth. So I know the volume of my sphere is 4/3 pi r cubed. And again, I really encourage writing that each time. That's the quickest and easiest way to actually memorize it. So for my volume for my sphere, I have 4/3 pi. Since they're giving me the diameter of that sphere, I know the radius is going to be 5, and that's cubed. And at this point, I'm just going to put this all in my calculator. Actually, I'm going to show it to you 2 ways. We'll do it exact, and we'll do it rounded to the nearest tenth. You do not have to show it exact, but I know a lot of you like to leave it exact, so I'm going to show you both answers. Now, when I'm doing this exact, I'm going to enter everything into my calculator except that pi. I'm going to ignore that for right now. So what I'm going to do is I'm going to do 4/3, and then I'm just going to do 5 cubed. So that's going to give me 500/3. Now, I know I need to multiply that by pi, so I'm going to get 500 pi over 3. And that would be centimeters cubed. Now, if I want the exact answer, I'm just going to multiply that by pi. It's going to give me 500 pi over 3, and again, I'm going to use this double arrow key here. If I press that, it's going to turn it to a decimal. So I'm going to get 523, and let's see, if I'm to the 10th, 523.6 cubic centimeters. If you leave it exact, again, that's fine. If you round it, this is the answer that you should get. So you should be doing this on your calculator with me to verify that you're getting the same answers. Okay, my next one clearly is a hemisphere. So I know my volume is going to be 1/2 of my 4/3 pi r cubed. So I'm going to have 1/2 times 4/3 pi. And in this case, they did just give us the radius. So I'm going to plug in a 4 for my radius. And again, we'll go ahead and we'll do this exact first. So I'm going to type it in just as I see it. So 1/2, then a set of parentheses. Now I'm going to do 4/3 times pi times my 4 cubed. And then I'm going to close those parentheses out. So you can see I've matched my parentheses inside here and then my 2 outer parentheses. So it's in my calculator just the way that it is. And actually, I'm going to take this back. We want to do that exact, so I'm going to type in all the numbers and not the pi. So that gives me 128 over 3. And again, if I'm leaving this exact, I multiply it by pi, so I get 128 pi over 3. Whoops, sorry, this is meters cubed. So now I'm going to multiply by pi. There's my 128 pi over 3. I'm going to use that double arrow. And to the 10th, I get 134.0. And again, that's cubic meter. Okay, those are as tricky as spheres can get. So there's not really a whole lot to it. So let's go ahead and go backwards now. If we're given the volume, now we're going to have to find either a radius or a diameter. So if I scooch down here to number 3. Okay, now we want to find the radius of a sphere with volume 2,304 pi cubic feet. So again, my volume is 4/3 pi r cubed. It tells us the volume is 2,304 pi. Please do not forget to take that pi with you. That makes a big difference. And that's equal to 4/3 pi r cubed. So the first thing I notice is there's a pi on both sides, so I'm just going to cancel that out. I'm really dividing by pi on both sides. Now I want to get rid of this fraction, so I'm going to multiply by the reciprocal on both sides. I know that 4/3 times 3/4, that just gives me 1. So all I have left here is r cubed. And now I'm going to use my calculator. I have 3/4 times 2,304, and I get 1,728. Now, since this is cubed, to undo that, I need to take the cube root of both sides. Just like if it's squared, we take the square root. When we have something cubed, to undo it, we take the cubed root. So in my calculator, I am going to do, okay, I entered my 3. Let me do that again so you can see it. I do the 3 because it's a third root. And then I'm going to do this second caret. So that's taking here now the third root of 1,728. And I get the radius is 12. Now, since we're just finding that dimension, we're just going to have our basic unit. So our radius is 12 feet. Okay, last one to go. Nice short video for today. Now we're finding a hemisphere, and the volume is 486 pi. Again, don't forget your pi. So the only thing I have to be careful of here is I have 1/2 times my 4/3 pi r cubed. Let's see. My volume now is 486 pi. Now in this case, to simplify it, I am going to multiply the 1/2 and the 4/3. I know that 4 divided by 2 is just going to give me 2, so really this comes down to 2/3 pi r cubed. Again, I'm going to multiply, well, let's actually divide by pi first, get rid of those pi's, and I'm going to multiply by 3/2 to get rid of that fraction. So I have r cubed left over here on this side. There's my calculator again. 3/2 times 486 gives me 729. Again, that's the radius cubed, so I need to go ahead and take the cube root of both sides. Again, to do that, I'm going to type in 3. Then I do second and the caret, so that gives me the cubed root. I type in 729, and that gives me a radius of 9. Now I have to be careful. This actually asked for the diameter, so I need to multiply that by 2. So my diameter is 18 inches. Okay, that's it for today. Short and sweet. We'll get practice with this before we move on to the last section, which will be composites.